Alright, we are going to come back with more Sega Mega Drive controller fun. So this thing here, this is a fake one. So last time we built, actually I'm going to take this apart, this thing that I've got. So we built this thing here, which was meant to be a homemade Mega Drive controller, or Sega Genesis controller, if you will. So one of these things. So these buttons do actually match up, and we got this to work and played around with it. So this does work fine. And then I said that the next step was, of course, to build a tester for this. And originally I built this thing because I tried to build a tester and then I broke it. I broke one of the controllers by wiring it up wrong. So I thought that if I made this thing, well, I can just change the IC, because I've got like 10 of them. So I've got a bandage on my finger because I've had a few cuts and scrapes. And so I've done that, and in fact, so the idea is we're going to do this with an Arduino first, and then we're going to do this with, so I'm just taking things apart, so with an Arduino, and then we're going to do it just with ICs for fun, and then we're going to move on to other controllers and other things. Don't worry, I've got a whole bunch of things I want to do on this channel. It's just getting hard to do. Mainly because I spent a very long time, actually, well, not a long time, but I made this up, which is going to be my Arduino-based Mega Drive controller tester, and it's a very bizarre one, and it's simply just so that I can make the code slightly interesting, because otherwise it's kind of straightforward. So this is using a 4511, which is the LED driver thing for the 7-segment things. So that's basically all this is that, and the wiring for this thing here. So this is just a 9-pin connector that goes into here, plugged that into there. I've got a ton of these. I literally bought like 100 of them recently, so I'm like, I've got to find uses for them. So this is my first use. So I've got one down. And I had to, I think I mentioned this in the last video I did, when I tried doing it, the display was very dim, and I thought that was because I used a 470 ohm resistor, which didn't seem too bad. Like, I thought like that shouldn't be a problem over here. So these have got current 470 ohm current limiting resistors, and the data sheet says 150 ohms is fine. But then I thought, well, maybe that must be the problem. So I actually went through and I, in parallel, did some 220 ones, which are underneath here. And that still didn't actually help. It didn't really work. Even though I was getting 150 ohms, when you put them in parallel, with the 470s and the 220s, you get basically 150 ohms coming out of here. And so I was a bit confused. And so I had to go through, and I finally worked out that my ground line, I had actually put, I was going to, hold on. I do have one right here. Alright, I was going to, I'll take this one out of the packet. I put what I thought was the ground line into the analog reference pin. So the reason for that is that these things are kind of funny. I don't know if I can find it. They sort of go off diagonally. Is that going to show up if you get real close? Like here. And so I'd done it with the ground, and it looks very hard to see, but this ground here, which should have lined up when I was looking at it with the analog reference pin. So actually it was drawing all of its current, I guess, sinking the current through the analog reference pin, and so that's why it wasn't working. So once I changed that over, it worked fine. And then I had two wires here that were on the wrong side, so that was pretty good though. So I got most of these all wired up correctly, and then I had to rewire those the opposite way around again. So the numbers came up wrong, but that's all been done. So 2 pins on this thing were wired the wrong way around. That was the easy fix. And there was a problem with this one too. I think I wired something up the wrong way on this. But in the end, finally, I made myself a little Arduino Shield board. This is the second one I've done. The first one I did was a little Simon Says game thing, which I'll go through at some point. A long time ago. So does this thing work? That's the big question. And then how does it work? And then we're going to look at this. We're going to look at the code to see to see how I actually wrote this. We'll put this back in here. I've been always looking for, like, I always get annoyed at these things because they don't have like a power rail they should have like 2 power hours so that you don't have to painfully go through and work out clever ways of getting everything to meet up at the one point. Like, I'm not the kind of person, I know that some people, they always do that thing where they solder big long lines around everywhere, but I don't like doing that. First off, I'm not very good at it. Second, it feels like it's a huge waste of solder. And I don't know, I quite like the whole having a whole pile of wires all over the show. I tend to prefer them on the top too, though occasionally they are on the bottom, as you will see for the Pong game that I am slowly working on finishing up. But anyway, so we plug it in. It always comes on and shows some random numbers at first, so I guess it's just random stuff coming out of the Arduino when it powers up. So if you remember what this chip does, it just takes a 4-bit number. So 4 lines from the Arduino are going into this IC, and it's turning that number into a value between 0 and 10 and 9. So we'll plug in to my fake controller to see if it actually works. So with my fake controller, all I've done here is that I'm indicating the button you're pressing by a number, which is kind of dumb, but it doesn't really matter because you're only testing the controller, so you just want to see that it's a different number for each thing. So if I go left and right, I think it's left and right, they're 1 and 2, and then you've got 3 and 4 for the next up and down, and then you've got 5, 6, 7, and 8 for start, I think it is. So as you can see, it all seems to work from my fake controller. So they control my homemade controller. So the question becomes then, does it work? And I really should turn it off, I guess, because I don't have anything to protect anything from blowing up here. So, like, I don't know if the computer does. Like, I've always taken joysticks out of the computer while they're running, and every single magazine when I was a kid said, don't do that. They're not like USB ports. They're not designed to have things yanked in and out of them, but I don't know. There you go, so we'll do the random things, and that's down to 0. So we now got this plugged in, and so does it work? Well, we'll go up, so up and down 1 and 2. 1, 2, 3, 3, 4, 5, 6, 7, and start. And we don't have these buttons yet because their 6 buttons are done slightly differently, but with this thing here, we will go through and add in. It's kind of easier with the Arduino code, so I will do another video talking about how we cope with the extra buttons. I don't know if I'm going to get that one done. That's going to be too involved a project, I think, to get all 6 buttons working for a IC based tester. I don't know if I could make a fake joystick with just ICs. I mean, with an Arduino it's quite easy, but we'll see. So we'll come back to that later. So you can see it does actually all work. So the last bit for today's video is just to see how the code works. So just a reminder, so 4 of these pins are connected up to the 4511, which is the LED controller. And then we've got 7 more, I think, connected up to this thing. So we needed 6. I don't know if I've got it sitting. No, I seem to have. Sorry, I've gone and left the piece of paper. It's miles away. I'm going to go get it. So hold on a second. Alright. So just a refresher from the video before about how these things work. There are 9 pins. 6 of them are basically inputs that we care about. Some of them, there's 2 power lines, which are 8 and 5, so we don't have to worry about that for pins. Those are just shared off the Arduino. Select is an output from the Arduino, and it's an input into the controller. So this is one pin that we're going to be using as an output. And then we've got 1, 2, 3, 4, and 5, and 6 pins that we're using as inputs. So yes. Alright. So how did I do that? So we'll just start off with the code. We'll turn this off so we don't have a bright red thing going on in the background. As mesmerizing as it is, though I wish I had common cathode blue ones and not the common anode ones. I do actually have a setup. I don't know, I can't see where it is at the moment. Oh, here it is. Alright, I don't know if it's going to... This was a controller thing that I built a while ago. It might actually work. I'm going to get distracted for a second. If I plug it into here. There you go. So that's what the blue ones look like. And that one's just running... That's running straight... That's being like... I'm using 7 output lines from the Arduino Nano to control that. So that's why I can do that with the common anode thing. But anyway, they look so much nicer when they're blue. So I have to invest in some blue ones. Well, the red one looks cool. Anyway, the point is, we're not here for that. So going through the code, we'll just start from the top. So here I've just defined a whole bunch of constants just so that I can label the pins. So in this case here, these are names of the numbers that show up when you press the buttons. So up is 1, down is 2. So those actually match up with what you saw when I was pressing the buttons. And I've just defined here that the select pin is pin number 6. And we've got the joy pin, so we're going to go through this. So I don't actually go through and define each pin for the inputs individually. I just say there are 6 pins and that they start at pin number 7 on the Arduino. And down here I was a bit lazy when it comes to to setting up the 4511 stuff. That's just the digits, that's just the 1's column, that's the 2's columns, that's the 4's columns, and that's the 8's columns in our binary representation of numbers between 0 and 16, but we're only using 0 to 9. And they're on pin 2, 3, 4, and 5. So I didn't use pin 0 and 1 because they're the serial pins. And I was using the serial for debugging. And so if you go from 7 and you add 6, you get to pin, well, you get to pin 13, but we've used up 7, 8, 9, 10, 11, 12. So after all of this, we've only got pin 13 left plus the analog input pins, which I could have used. I could have used the analog input pins for this, I guess. It's too late now because I've wired it all up. I mean, there's no reason why I built a little board. I should have just done this on a breadboard. Because it's a very silly project and I want to do it with the ICs, but hey, it's fine, we'll go with it now. So down here I've got these 2 arrays, and this is where it gets kind of where I've done things in a bizarre way. I've got with the select, and then I've got without the select, and I'm using 0 to say it doesn't mean anything. So what's going to happen is basically I've got one little routine that goes through and it tests through each of the pins, the input pins, whether that is being held low. And if it's being held low, I will look up in the array the equivalent value from these arrays, and that will be my answer. And this will make a lot more sense in a second. So that's just the preamble of the stuff where I'm just defining some constants. So here's the base part for reading in a pin. I don't know how well this is going to be readable on the screen, because this looks a lot smaller now than I thought it would be. So we're going to read in base. So what does this do? So this is taking in a pointer to an array. So in this case here, the star, remember, means a pointer to. So this is my lookup array. It's either going to be, I'm either going to be passing in this array or this array, as you'll see. And then we've got the first pin. This is just being silly. It's always going to be pin number 7. So I'm always going to be passing in that. And this is going to be the pin. So I tried to make this a general function, but I mean it's not going to be used for anything else, so it's a bit silly. And I feel like I've put, no I haven't. Okay, cool. I've put like semicolons in bad places, but anyway. So that's going to be 6. 7, and that's going to be 6, so that doesn't really matter. So we're going to go through each pin, and then we're going to say, as I said before, if that pin is being held low. So we're going to go from 0 to 6 in this case, and if a particular pin, so we'll start at pin 0, and we'll say, which is, first pin plus I, which is going to be 6 plus I, so I is 0. So it's going to read in the value on pin 6, the first rhyme through the loop, and if that is 0, I'm going to return the ith value of the lookup array, which is going to be, I goes from 0 to whatever. So if in this example here, if I was holding down the up button, for example, and then I was looking through this array. Then when I get to here, and so the important thing here is that pin 6, sorry, which is the first pin in my input set of pins. I should have drawn a picture actually. I think it would have made things a lot easier. But that will be connected to this pin here. So this is going to be pin 6, pin 7. It's going to be connected to those ones. Pin 8, I'm assuming, is connected to that one. I missed out some, right? Pin 7, pin 8, pin 9, pin 10, pin 11, and pin 12 is connected to these input lines on the actual controller through the little plug thing here. Right? And so if any of those are being held low, that means the button is being held down. So I'm just going through to find which pin is being held down first. So this thing doesn't detect if you're holding down more than one button at a time. It will just take the very first one that you get. Which is fine because I'm testing things and I'm just testing the buttons individually. Which is not good because you really want to test the dynamics of the diagonals as well, but hey, you know, we can't have everything. When we do the IC version, it will use LEDs and it will be much easier. So if the result is, what did I say, is greater than 0. Oh yeah, so I've got, if the result is greater than 0, then you get the result. Otherwise you say 0. So I'm using 0 here. The only reason for this. So there are 2 zeros here. So this is with select. And if you have select without select, you've got up, down, but these are always going to be pulled low. So it's kind of like a hack. So when you have select 0, left and right always read as being held low. So if you didn't take any sort of special care of this, then you would always think that left and right are always being held down, because when you put select to 0, it's going to come up as being low, and then you're going to go, oh okay, left and right are held down. When I put a 0 here, I just say, well, okay, if it's being held down, I don't care, it doesn't mean anything, so just skip over it. Which is what that code does. Basically, if it's 0, it won't return the value, it will just keep doing the loop. But if none of those buttons are held down, then it will return 0. So 0 in this case means you didn't touch anything, nothing is being held down. So that's the base function, but then you've got the read pin, which basically does it twice. So it's going to be doing it, you're going to first set the select pin to low. Oh, I forgot to take up the show pins thing. Oh well. So that's actually debugging information. Probably should have checked the debugging thing. So you can forget about this for now. That's just showing the pins. That was to debug the code. We don't need that one either. Oh, it's a terrible pen to use. It's very hard to say pin and pen over and over again. That's gone, and that's gone. That has not helped at all. It's made it a lot messier. So first off, we set the select pin to low, and then we go without select equals read in the pin base. We're going to use the without select array. So in this case here, the actual value of that variable is the pointer in memory. So I know that the thing here, I've used this as capital letters. When in fact it's not a constant, it's an actual array, but I just don't know how to do well, you can't really do constant arrays in effect. Basically you have to store this in memory somewhere and you have to reference it. I'm just treating it as a constant, so I'm just saying I'm not going to change this array ever, even though technically you could go through and change those values in the code. But anyway, so this is the only important thing is, you might say, well, shouldn't there be an ampersand in front of here saying I want the location, because I'm getting past a pointer to something, so I want the location of this variable that I'm going to pass to this function, because this function is taking a pointer to an array, and and then so I should have an ampersand, which means get the location in memory of this variable, not the actual variable itself. But in this case here, because it's an array, that variable essentially is, an array is essentially a pointer in memory to something. It's not actually the array itself. So you don't have to have the ampersand. And then again, so those are those two. So as I said, this is going to be 6, and this is going to be, so this value is 7, and this is 6. So these are just the constants I defined beforehand. And we're going to read it in without select. Okay. Oh, it's a bit weird. So then so the next part is then I set select to be high, but then after that I'm checking it. I could have actually moved that one over to there. This probably shouldn't have been there. It should be the next thing over. So here I'm saying if without select is greater than 0, then we'll return that value. So that means we found a pin, and that's returned something from that array. So we don't have to do anything else. But if it isn't, if it is equal to 0, then we're going to do exactly the same thing, but this time we're going to pass in not the without select, but the with select array. And over here we've set select to high. So then we're going to read in the alternative values from the MegaDrive controller. So I hope that kind of makes sense. Whenever I do these things, it always seems to be a lot harder to make it sound like logical than it really is. I don't know. So even explaining why I find it hard is very hard because it makes no sense. So this is just my debug thing. This basically is very similar to the other code, and it's just going to be printing out H or low, depending on whether or not that input from those pins is high or low. So it doesn't really do anything, except it was just to help me find out whether or not it was actually reading the values from the controller in the first place. So I'm just thinking it's actually probably going to be a bit tricky in the end if we're going to do this with ICs to cope with these two things here. But hopefully I can work it out. So now we've got the last bit with 6 minutes left. We have to do this kind of quick. So setup basically just sets the joy input pins to be input with a pull-up. So I put in the pull-up there. So this tester should hopefully work actually with a straight old school Atari 8-bit controller, which I haven't got sitting next to me. I haven't actually tried it yet, but it should work because it's using the pull-up. And I don't think the 5 volts that are going in is going to cause it any harms, but I should double check before we test it. And then we're just going through here. So the select pin is an output pin. The digits, I feel like I'm missing. I am missing a few things. We're gonna have to. All right, I'm going to stop the video here, and then I'm going to continue on and talk about the last interesting part, which is the 4511 bit. So let's go read that one more time. Thanks for watching, and I'll be back real soon.